Hello, my name is Robert Mitchell and welcome to this episode for Electropages. Today we're at the Embedded World in Nuremberg and I'm joined by Matt Burns from Samtec.
Way to go, Rob. You got it right this time.
Got it right this time. Yeah, it's pretty much. Right, so you wanted to demonstrate this new 56 gigabit system you've got going here?
Yeah, Robin. So first of all, we're excited to be here at Embedded World with Electropages. So thanks for the opportunity to talk with you and your audience. Awesome. One of the things that we're demonstrating today here at Embedded World is what we're calling our 56G product demonstrator. Right. And really what this is an effort by Samtec to show our customers and our partners what our products look like in a real world system. Yeah. Now, Embedded World is typically going after embedded applications, so you kind of have to imagine this in an embedded data center.
Right.
But this is really mimicking or emulating our products in a 56 gigabit per second backplane application. And what we've done is we've partnered with semiconductor company Credo, who makes high-speed SerDes and high-speed retimers at 56 gigabit and higher speeds. And so we're using their chipset to run the electrical signals through the system, and then we're running their signals through 4 of our products on the chassis. So I can just step you through those very briefly and then take a look at some of the detail. So one of the first products we have is what we call our Flyover QSFP DD, which is designed to be a front panel pluggable solution that uses our Flyover technology inside the chassis.
And that's an integrated electronic solution right there.
It's a passive cabled solution.
Oh, right, okay.
But it can route data at 56 gigabit per second, 56 gigabit per second PAM4 and faster.
And it includes a connector as well. And
it does. It has the front panel cable. The difference with our Flyover technology is instead of the signals entering into the front panel using an edge mount connector and then going down to the PCB, we attach our Flyover cable directly to the edge card so that makes a cleaner SI signal.
All right.
The other advantage is having the cable in the back end, you can route the signals a lot longer. So in this particular channel, we're going Credo, QSFP DD, standard DAC cable, QSFP DD. It's about 2.5 meters or so in length. And if you look at the results here, we're showing a BER of about 1 e to the minus 14, 1 e to the minus 15, depending upon the channel.
These are eye diagrams, aren't
they?
Those
are real-time eye diagrams. You can see on the 4 channels, we've got wide open eyes using the PAM4 data.
Which is good for signal integrity. So.
Exactly. If you saw those eyes closed, you'd know that the signal would be bad. So that's one channel. The second channel that we want to illustrate is what we call our Accelerate cable. Accelerate is really a high-density, small form factor solution that's designed for routing data over Flyover technology from ASIC adjacent either to the front panel or to the back plane. In this instance, you can see the Accelerate sitting right next to the Credo
small metal pattern chip, basically.
Exactly. Yeah. So here's the Accelerate cable going from, it's a right angle version, from board 1 all the way up to board 2. And you can see from the data also, we've got BER about 1 e to the minus 15 and wide open eyes.
Is that one also 56 gigabits?
Everything in this system is 56 gigabits. So great question.
And I think we should appreciate that in total. You said it's about 2.5 meters length.
On some of the channels, you have 2.5 meter length. Obviously, this is about a half a meter or so.
But if this was a PCB trace, for example, you couldn't get anywhere near that distance on that frequency.
Typically, yes, but you'd need a retimer or a CDR.
Exactly. So you've got all that additional hardware to try and propagate that signal throughout your system, whereas this thing is a single passive cable from one place to another.
Yeah, and it simplifies the design at the PCB level. Yeah. One other solution we want to talk about is our XMAX backplane connector. So this is a very traditional right angle
that's these ones right here.
Exactly. Yeah. So very traditional right angle backplane. XMAX is something that we second sourced from Amphenol FCI. So you can see you're going from the Credo chip to the backplane. The nice thing too about this system is we can pull and add these chassis or these line cards up and down the chassis. So you can see there's about 8 or so different positions between the 2 ports. We can move this up to, we can move this down to, and what that enables us to do is to test various backplane signal channel lengths as well. So XMAX is very traditional backplane, very traditional 56G solution, but it still works very cleanly. And you can see here, BER of about 1 e to the minus 13, and then nice open eye diagrams as well. The last solution that we want to talk about is just the Accelerate Mezzanine. We talked earlier about Accelerate cable, Accelerate HD. Yeah, exactly. Yeah. Accelerate HD has a couple things going for it. 56G PAM4 interconnect, 0.635 millimeter pitch. It's configurable, so we have many options, anywhere between 4 by 60 all up to 4 by 100. So we can support anywhere between 240 to 400 pins within the solution. Various stack heights from 7 to 16 millimeter. You can see here on the mezzanine, it's just a daughter card. So chip, daughter card, loop back to the chip. up on top here as well.
Hence the name mezzanine. So
Exactly.
That makes a lot of sense. It's basically an additional layer.
Exactly.
Right. Okay.
Great question. So here you can see that for BER, it's a short trace lens, so the BER is pretty clean. It's about 1 e⁻⁻15, and again, open eye diagram.
And so the connection itself it's more like it's like two connectors essentially.
Exactly.
Okay.
One male, one female. The mezzanine style interconnects enable attaching a daughter card to.
And would that be used for things like compute modules?
Exactly.
Right.
So if you here at Embedded World, you see a ton of compute modules. You see solutions from a good example. AMD has their Credo platform. It uses Accelerate Mezzanine. So that's nice. That's nice overall overview of all of our 56 GPAM4 products here at Embedded World.
Now, for the engineers who are watching this episode, if they want to get involved with Samtec technology, what's the best thing for them to do?
A couple things. They can visit our website, www.samtec.com, or they can email our technical experts at sig@samtec.com as well.
Fantastic. Well, thank you ever so much for taking the time to see us today.
Thanks so much for the time today. We appreciate it.